Welcome to this video on getting started with MobX. My name is Eric Green. This video is brought to you by Wintellect Now. In this session, we're going to take a look at the different aspects of getting up and running with MobX, and specifically using MobX within a React application. We're going to start off first by getting a good overview of what MobX is and the problem that it solves. Then we're going to take a look at setting it up, and specifically setting it up within a React application. We'll talk a little bit about working with state and then how to initialize and change state. Then we'll take a look at computed values and how we can use those. Then we're going to take a look at how to connect imperative code to reactive code. And we'll do a little demonstration of connecting React to MobX using observers. Then we're going to take a look at passing the store via the React context, and we'll use provider and inject to pass in the MobX store. So in order to first understand the problem we're trying to solve with MobX, we first have to understand what exactly is application state, and why is state important in an application. State basically represents all of the data that an application is using in order to actually run and execute. Now, state can be the actual data that the program was created to manage, but state could also be things like related to the user interacting with the application, things like storing the current filter value for filtering on a column, or sorting on a column, or which product is currently selected. So state involves both the data being managed as well as session information generated by the user as they're interacting with the application. Now, managing state in modern user interface applications can be difficult and inefficient. And in fact, a lot of the bugs and stuff that will creep up in the development of these modern UI applications are all related to state. Now, managing state can be really challenging, and one of the big reasons for this is because the word state is really overused. Different libraries and frameworks and stuff like that actually have parts of them that call certain things state, and then you have the general concept of state that applies to all of this data. So for example, React, you have this local component UI state. Well, yes, application state is included in that, but all of the props data is also truly application state as well. It may not be state from a React component UI perspective, but it is actually state. And so understanding first what we mean by the word state can actually be really, really difficult, especially if we try to equate it to where that word is used specifically in other frameworks and libraries. Now, applications which are not designed well tend to manage state throughout the various user interface components. So when we say not designed well, we don't mean that there can't ever be any application state stored somewhere else. We're just saying that as a general rule, there shouldn't be state sprinkled all throughout the application. Instead, that state should be managed in one place and then passed in to the various components. So better designed applications actually tend to remove that state from the user interface and then store it external somewhere to the user interface in either one or more locations. So a common question is, what state should be stored externally and what state should be stored in the UI? This is even more challenging and definitely filled with debate. As a general rule, if you're not an experienced UI developer and you're not really sure where to put what, it's actually best to just take all of the state and move it out of the UI. While I will argue against doing that in certain cases, for the most part, if you're not sure where to put it, it's better not to put it in the UI, manage it outside of the actual UI structure, and then pass everything in. Now, of course, the library that's going to introduce an interesting problem with this approach, though, nevertheless, is going to be actually React. So React has this concept of a controlled component. And what basically a controlled component is, it's an input field or a select box or text area that is basically bound to local state, and as you type into the box, it triggers a re-rendering of that component to reflect the actual characters being typed into the box. Now, this is something that's really peculiar to React. If you work with other libraries and frameworks, you're not going to see this kind of behavior. The problem, though, is that this controlled component uses state, but not the larger application state that we're talking about. We're talking about this React UI component state. Well, as a general rule, we don't want our React UI components having state, because typically that state is really application state. But in the case of having controlled components, that's kind of like the one little exception. Because the purpose of that state is really just to facilitate the mechanism by which React actually updates input fields. It's not because we're really trying to manage state overall. We just need a way of collecting the information so that when the form gets re-rendered, it gets re-rendered with the updated input content. Now, we can actually avoid this problem if we use something called uncontrolled components. But as you'll read in the documentation for React, uncontrolled components are not generally recommended because they kind of go against the whole concept behind how React updates the DOM. Nevertheless, they would eliminate this confusion about UI component state. I would make the argument that if you're using controlled components, track the state for those within the form component that you're working with. Don't try to push that out to some type of state management tool like a MobX or a Redux, because that's not really application state. Not really. It's really just a little mechanism to collect a little bit of form data because of how React updates the DOM. So what exactly is MobX then? MobX is a tool that we use to manage application state. And there's really three core concepts to MobX that you need to know about. First of all, actions are any code which can change the state. So clicking a button and saving some data, maybe deleting a record from a table, maybe changing your filter on your table, sorting by a different column. These would all be actions. State is the data which drives the application. As we mentioned earlier, this is the actual data as well as data related to the actual user session. Now, the way that MobX is going to manage this state is that the state itself is actually observable. And so there will be things observing the state, and when the state changes, the observers of the state are actually triggered automatically to then use that new state data and update themselves. Now, in MobX, and really any state management container, state should really contain the smallest amount of data. We shouldn't really be storing computed values and things like that. They are going to come under a different section called derivations. Derivations are computed values and reactions. Computed values are basically anything that we can calculate from the state. So for example, if I had a shopping cart with 3 items in it, I wouldn't want to store necessarily the total value of items in the shopping cart on the state, because I can derive that by computing the actual shopping cart items and their price to then generate the total price of the shopping cart. Then reactions perform side effects, doing things like updating databases and calling REST services and stuff like that. So here's a little diagram that kind of shows you how this works. An action enters the system, the state is updated, and the views are then updated with the new state information. So we can kind of summarize it. An action is executed, state is mutated, and the views observing the state refresh themselves. Now, the source of an action is always going to be an asynchronous operation in the web browser. This is not a MobX thing, it's just how things work in a web browser. The change to state is not an immutable operation. If you come from a Redux background, you're probably used to the concept of the state is always immutable. That is not the case in MobX. In fact, that's the value proposition that MobX offers. You don't have to do all the immutable programming stuff. You can just write normal programming code, and then MobX has a way of handling all of this to then let the views know that the data has, in fact, changed. Views are the observers of the observable state, and in this case, we're going to be using React for our view library. To get started with MobX, we're going to need to set up an application to be able to run our MobX code. We're going to use React, but technically React is not required to use MobX. You can use any view library that you would like to use. You can actually choose to use no view library at all, but it turns out in the developer community that React and MobX are actually a popular combination. So a quick way to set up a React application is to use the Create React App tool. This is actually maintained by Facebook, And in order to use it, you will need Node version 8.2 or higher. And we'll actually demonstrate how to set that up in the actual demo that we'll do for this section. In terms of getting the application up and running, you're going to use the npx command. Now, you may have used Node before, and you may have been using it for a while, and you may not be familiar with the npx command. It's a relatively new command, and it will actually install Create React App itself, and then allow us to also create our new application all in one command. And as part of creating it, it will actually download all the dependencies and everything else that we need for the application. So we'll say npx create React app, demo app, and then we'll change into the demo app folder, which will have the newly created React application. Now, to actually use MobX with our React application, we're going to need to install it. MobX is distributed via npm, and that's actually how we're going to be installing it. But you can also download a UMD module off of a CDN. You can also use MobX with JavaScript and TypeScript, although we will be using it with JavaScript. MobX actually has support for decorators, but to use these, you'll need a special plugin for Babel or have to use TypeScript. So we'll take a look at how to set that up as well. To actually get up and running, though, with MobX, you'll actually need to say npm install -e mobx -save. If you're on the newest versions of npm, you can leave the -save off. But the -e is going to tell it to basically install this specific version, and when you reinstall the packages in the future, to also reinstall the specific version installed today. I've found that when working with Node and npm, it is always best to say the exact package, because you never know what type of updates people are going to include, even in a minor version or a patch version. So it's always better to install the exact. Now, in addition to pulling down MobX, we need to pull down the package that allows us to connect MobX to React as well. And so we'll say npm install -e mobx-react -save. Now, decorators. Decorators are a really cool feature of working with JavaScript, except that it's not actually a JavaScript feature. Turns out that decorators are basically a way of decorating or annotating your code to describe functionality that it's going to have and then have that functionality applied. Unfortunately, they were not added to ES 2017, and making things even worse is that there's actually two different types of decorators out there. There's an older version, a legacy version, and then a newer version, which is still being formulated. So in order to make all of this work, we're going to actually have to find the right decorator transformation plugin for Babel. And then we need to be able to add that plugin to our Create React App application. Problem is, that type of capability, the ability to add a new Babel plugin, is not supported by Create React App. So we're actually going to have to find the correct decorator, and we're going to have to ultimately eject our Create React App application from our Create React application tool. So to set this up, we're going to have to install the Babel plugin Transform Decorators Legacy package. This package is going to have the older implementation of decorators, which is what MobX currently uses, so that we can then do our MobX development. After we do that, we are then going to have to eject our Create React App from the actual tool Create React App, so we can then update the Babel configuration to use this new plugin. To actually eject the project, we're going to say npm run eject. And then we're going to go into the package JSON file, and we're going to add the plugin Transform Decorators Legacy. If you look at the package JSON file before the ejection, you will notice that there is no ability to configure the actual Babel plugins. You have to do the ejection to make that work. Now, MobX can actually run in two modes, normal mode and strict mode. Strict mode is preferred. Basically requires that all state changes occur in functions that have been marked as actions. This is a best practice. So we're going to go ahead and turn it on globally and get that up and running, so when we write all of our MobX code, it will be running in strict mode. Let's do a demonstration now of creating a React project with MobX. So let's get started here setting up our MobX application using React. We're going to need Node.js, and we're going to need an editor. So let's open up Chrome here. And we're going to go to Node node.js.org. You'll see you have a choice of downloading the LTS or the current version. If this is just your own personal machine doing your own thing, I recommend grabbing the current. A lot of times in the enterprise, though, folks will use the LTS, the long-term support version for new projects. That way the actual node version will be supported for an extended period of time. We're going to go with current here, but either one will work fine for this application. Just make sure it's going to be the 8.2 or later version of Node, just in case you already have Node installed. So we'll click on this and download it. It's going to download an executable for us. The other thing we're going to need is we're going to need Visual Studio Code. Now, you can use any editor you like, but I like to use Visual Studio Code. So we'll download Visual Studio Code here. We'll click on the download for Windows. We'll let that download. All right, now that Node has finished downloading, and while Visual Studio Code is downloading, we'll go ahead and install Node. So we'll click on the link down there. We're going to click Next. We're going to accept the license agreement. We'll go with the default path. Then we're going to go ahead and stick with the default options here. Click Next, and then click Install. Great, so now that Node.js is installed, we'll click Finish. Then we're going to come down here and run VS Code. Go ahead and click Next, accept the agreement, Next, Next, Next. I'll add it to the path. I also like to set it up so that it will actually add the Open with Code to the context menu of Windows Explorer. And we'll go ahead and click Next and then click Install. That'll take a minute or two to complete the install. Great, so now that we have Visual Studio Code installed, it's going to give us the option to launch Visual Studio Code, but we don't want to do that quite yet. Go ahead and uncheck that and click Finish. We can close our web browser now. Next thing we're going to do is we need to open up our command prompt window. You can do so by coming into here and scrolling down here by going to Windows System, and then there's command prompt right there. I also have command prompt set up here on my taskbar, so I'll click on that one. There's my command prompt. Next thing I want to do is I want to change into my project folder. So I'm going to be storing all my projects inside of Git W now. You'll see my folder there is currently empty. And what I want to do now is create a new React application. So I'm going to say npx create React app demo app. So npx is going to download the Create React App tool as well as set up the project and install all the dependencies for that project. Excellent. So now we've got our Create React application all set up. We're going to go ahead and change into the demo app folder. So now we're inside of demo app. Now what we need to do is install a couple of additional packages. The first one we're going to do is we're going to npm install. You can type out the word install, or you can just say npm i -e. This will be the exact version, MobX. If you're using a version of npm less than version 5, you'd have to use the -- save to save the dependency. But because we're using the latest versions of npm are greater than version 5, so I can actually leave the -- save off if I want to. And I'll just run the command now to add it. So it's going to go out and download MobX and add it to our project. We're also going to do the same now for MobX React. You can do both of these in the same command just by listing both packages, but we've done them as separate ones here just to show you how to set it up. Now we need to install our Babel plugin for doing our decorators. So we're going to say npm install -e. This is going to be a development dependency, so we're going to put a -d in front of it. And we'll say Babel plugin -transform -decorators -legacy. Go ahead and install that. Excellent. The next step is we need to actually eject this project from the actual Create React App tool. And this is so that we can actually go in there and modify the plugins that are configured to work with Babel. So we're going to say npm run eject. And this will actually eject the project out of Create React App Tool. This is permanent. You cannot put it back into the tool. That's okay. That's what we want to do. Go ahead and eject it. And now it's going to update everything so that we actually have access to the underlying configuration, and then we can modify that configuration for our purposes. So now we're going to say code dot, and this is going to open up Visual Studio Code and use this particular folder. So now we have our files over here. We're going to want to open up package.json and scroll down here a little ways. You'll see here's our Babel configuration. We're going to come into here and we're going to update this to say plugins, array brackets, and then we're going to list our transform decorators legacy. We'll go ahead and save that. So now we're actually now using our decorators plugin. Our final step is we're going to go ahead and enable strict mode so that our MobX application will in fact run in strict mode. So we're going to come over here to our index.js file, and then right here at the top we'll just say import use strict from MobX. And then right here at the top we're going to say use strict true. Now to actually run the application, we're not doing anything really with MobX yet, but just to kind of run the application so that we can see the output of it in the web browser, we need to open up a terminal window here inside of Visual Studio Code. Yes, you can use this terminal window if you want, but because a lot of errors and stuff that could occur with transpilation will appear in the window, it's actually nicer to be able to have the window here inside of Visual Studio Code. To do that, you can say control backtick. So if you hit down control and the little backtick quote character that's to the left of the number 1 on your keyboard, that'll open up the terminal window. If you don't want to open it up that way, you can also come into here and say view integrated terminal, and there's that control backtick, by the way. So click on that and it'll pop up. To get this thing started, we simply say npm start, and this will fire up our application. And you can see everything loaded up properly. Nothing happening here really with MobX yet. This is just a confirmation that our project setup was successful. You can see it's running on localhost 3000, so you'll need to have your port 3000 available. And then if you come into here, you can see the entire compilation process and the result. There we go. So now we're all set up to get started with MobX development. MobX uses the concept of observables for tracking state. I want to say one thing at the outset. In case we have anybody watching this video who comes from an RxJS background, or maybe you've done some work with modern Angular, the observables we're talking about here with MobX are a completely different concept than the observables of RxJS. I don't want you to come in here and think this that MobX and RxJS is somehow kind of like connected together. Not at all. They are totally separate libraries. So what exactly is an observable? An observable is an object whose properties can be tracked. Basically, to track an observable means a function is going to be executed when the observable changes. So to actually start tracking an observable, basically the way this works is a function is going to be invoked. When that function is invoked, the code accesses the observable object's property, and it's going to retrieve the current value, but also register a function for tracking that observable in the future. Then when the observable changes, that function that was registered is going to be invoked again and will use the new value. Now this tracking is going to be set up through a function referencing the observable object's property. Internally, MobX is really just using getter-setter style properties, so that when you first reference that property using a getter, it actually runs some code to know that this particular component or UI piece is interested in tracking this particular property. To make changes to the state, action functions are going to be used to make changes to the observables. All right, now the functions may or may not be specifically marked as action functions, although if you're running it in strict mode, they have to be marked as action functions. But an action function changes an observable, and then any reactions which are being tracked on those observables are then executed. So any of the other pieces of code that use that observable, and as a result of using it, registered themselves as being interested in the actual output from the changes, all of those functions will be executed, updating those things that are paying attention to it. Giving actions a name can definitely help with debugging. Also, actions are typically passed into event handlers for controls like buttons and things like that. So actions can be configured to preserve the actual value of this. As you probably know, in JavaScript, the value of this is one of the more confusing things. So we want to make sure our action functions are configured so that our value of this, since they're being passed in as event handlers, will be the value that we expect it to be. So take a look at this here. Observables and actions can be configured with decorators or through functions. So we have our class demo with our @observable and @action. And so what will happen now is we can create a new instance of demo. We can call auto run and actually reference message. And then when we come in and say demo1.say test1, it's going to actually update message, which will then trigger the function register with auto run to actually execute. So you'll see when we actually registered that function with auto run and used demo1.message, that then registered it with the observable. And then when we said demo1.say, then it actually calls the function, sets the value, which then triggers the auto run function to run again. Now, if we don't have decorator support set up, we can actually use observables through their function syntax as well as action. And you can see here in the second demo, we have observable, and then we're passing into it an object literal with a message hello and a say property. And then that say property is having an action wrapped function assigned to it. But it ultimately performs exactly the same way when the code executes. Let's do a demonstration now of initializing and changing state. So let's get started here building our first observable. Up here we're going to import observable, and then down here we're going to create a class. We're going to say class shopping cart. Now in our shopping cart we're going to have a bunch of items. There we go. We're going to mark this as being observable. Now watch what happens when we do this. You're going to see that VS Code is going to complain saying that observables are an experimental feature. Unfortunately, this error really has nothing to do with our actual JavaScript code. It has everything to do with TypeScript. You might be thinking, well, we're not doing a video with TypeScript, we're doing regular old JavaScript. Well, it just so happens that one of the things that Visual Studio Code likes to do is try to provide you a lot of strong typing in your JavaScript code as much as possible. And even though we're not using TypeScript, it still actually applies a set of rules to your JavaScript code for the purposes of giving you this documentation as well as giving you warnings about certain usage of certain features. So to actually solve this, we're going to come down here and create a new file called tsconfig.json. And in that file, we're simply just going to paste the following configuration. We're going to tell it that experimental decorators can be used and to allow JavaScript. The allow JS is because we're not actually using TypeScript. And the experimental decorators is to make the error message go away. So if I save this and close, make sure you save this file too. And what we'll actually have to do is restart VS Code in order for this to be fixed. Ah, look, it actually fixed it without restarting it. Sometimes you have to restart it for it to go away. But actually we don't have to here. That's excellent. So now we have our @observable. We have our items. And we want to have the ability to add a new item to this. So to do that, we're going to define ourselves an action, which means we have to import action here at the top. And then we'll come into here and we're going to say @action, enter, and then we're going to say add, and then we're going to have our item that we wanted to add. And then we're going to say this.items.push item. Now for those of you who come from maybe a Redux background, whatever, you're used to working with state immutably, in those situations, of course, you would say concat to add something to the state. But here you'll notice we're just simply using push. We're not worried about mutating the array because of the way that MobX is set up, everything will be notified the array changed automatically. We don't have to write a bunch of code that does like memory reference comparisons, so on and so forth. So we'll go ahead and save that. There we go. Now we need to create an instance of our class and then actually add an item and see the fact that we've added the item. So we'll come into here and we're going to say const shopping cart equal to new shopping cart. Here we go. And then we want to take our shopping cart and we're going to want to add something to it. But before we do that, we actually need to register it with the auto run so we can actually see the code run in response to adding an item to the cart. We'll say auto run. And then here for our auto run, all we're simply going to do is say console.log shopping cart.items. And then we'll be able to actually see the items that are now in the shopping cart. So we'll save that. And then we're going to come into here and we're actually going to say shopping cart dot add. And we'll add an item, ID 3, name, we'll say a computer, price $3,000. Let's actually make that uppercase. Okay, so now we're adding an item to our shopping cart. Now, as you'll see down here on a previous save, we actually got a fail to compile. This is actually a really nice feature of working with these node-based tools is you get this automatic watching of your files, and when you save stuff, it'll then give you error information. So our problem here is our auto run is not defined, and that's because we just simply didn't import it. So let's take our auto run here, copy that, paste that into here, save it. All right, now that we've added auto run, we'll make one other slight little change here. We'll actually just output the number of items added to the cart. So we'll just say length like that. So now let's head over to our web browser and open up our developer tools. We'll go to the three dots, more tools, developer tools. And let's head over to here. You can see the first time it outputted 0. That's when it calls auto run the first time. It automatically runs that function that we pass in. And then when we added something, you can see now we have one item in the cart. If we were to head back over here to our code, and let's say we added 2 items. So now we'll add item 10, and this will be a mouse, and this will be a $50 mouse. So if we save that, and then come back over to the web browser, now you'll see we have 2 items in our array. So the way this is going to work is every single time we add something to the array, we're now going to be able to have code run that will run in response to that, and then we could update things, for example, in the UI. Now this observable array is really an array like any other array. Internally with MobX, it's actually stored as like a false array. It's not a true array. But we can do all of the array operations on it. So for example, in our auto run here, we could say console.log shopping cart. And then we could say map. And then we could take each, or shopping cart.items .map. And then we could say item, and then item.name. And we could build ourselves a little array of item names. So go ahead and save that and then come back over to here. You can see there. So now we just have computer. Now we have computer and mouse. Another important aspect of working with MobX is being able to derive values from the state. There's 2 kinds of derivations, computed values and reactions. As mentioned earlier, as little state as possible should be stored, and so really we want to derive as much as we can from the state. A computed value is really just a value that's derived from the state. Typically, some type of calculation or other transformation is applied to it. You can kind of think of a computed value as like a spreadsheet calculation. You have a bunch of rows with data, and then you want to sum up all the values. The sum is a calculated value on the spreadsheet. Well, that's how computed values work. So just like if you were to modify a field in the spreadsheet that changed, the price of something, it would change the sum. Computed values work in the same way. When an observable value is changed, the computed value is also recalculated as well if it's being used by something in the application. Now, there are a couple of limitations working with computed values. They must be a pure function, which means it can generate no side effects and no errors can be thrown. So it's not the type of place where you want to try to put a bunch of asynchronous code or have a bunch of complex error handling and throwing stuff. It should be relatively simple, fast code that does the computation. So here's an example of setting up a computed value. An important thing to understand about computed values is they are only recomputed when they need to be. So you could have 1,000 computed fields, but if they're never used, they're never calculated. This is one of the reasons why having things like side effects and errors don't work all that well, because it may never actually be computed to generate the error or the side effect that you might need. And so because of that, it's not something you can rely upon. They're only calculated when needed. And the reason why this calculation is deferred is for performance reasons. If you're not using the fields, then why spend the time recalculating them? Let's do a demonstration now of using computed values. In the last video, we learned about working with state. In this one, we're going to take a look at working with computed values. So we have our shopping cart here, and let's say we wanted to be able to calculate the total price of all the items in the cart. An initial thought might be, let's put this on state. So you might come in and do an at observable here, and then we'll say total price, set it equal to 0. And then you'd have to have a way to update that. And so maybe here inside of the action, we would actually update the price whenever we add a new item. So for example, we could come into here and we could say this dot total price plus equal item dot price. And we could save that and then come down here and we could actually output the price. So we could say console.log shopping cart dot total price. Go ahead and save that. If we head over to our web browser, you'll now see the price is updating. There's a 0, 3,000, 3,050 is updating each time we add something to the cart. The problem though with this, by maintaining total price as state, any type of operation that we do on a shopping cart item, we're going to have to remember to come in and write this piece of code to adjust it. So let's say we had a remove action. Not only would you have to remove the item from the cart, you'd actually have to write the code to subtract the price of the item that you're removing. Let's say you had a situation where you wanted to update the price. You'd have to go in and remove the old price and update the new one. Maintaining and managing all of this state can be very problematic. Somebody could come in and create a whole new method, not even realizing that total price needed to be updated. And then they would write their code and would change the price of something without remembering to actually update total price. And things can get out of sync very, very fast. Instead, it's always better to have a minimal amount of state and derive as much as you can from the state. For example, we can derive the total price of all the items in the shopping cart by iterating over the items and generating that particular value. So to do this, we're going to actually set this up as a computed property instead of an observable. So we'll scroll up here and we're going to actually import computed like that. We'll come down here and we're going to simply just change this to computed. And then we're going to have to change this to a function. So to do that, we're going to make it a getter property, which will enable us to have a function. And then we're going to write some code here to actually update this total. So we'll say return this.items.reduce. We'll have our current item, actually our accumulator in our current item. And our accumulator plus current.price, and of course we will initialize this to 0. So there's our total number of items. We're going to iterate over it, and we're going to produce the total price. Now we can get rid of the code here that updates the price. We don't need that anymore. And then down here, we can just continue to use the same total price property we had to begin with. So let's switch back over to our web page now. And now you can see we're still getting the total price, and it's being recalculated. So the question is, how often is this total price being called? It only gets called when items has been updated and something is actually requesting the total price. In fact, we're going to come in here and say console.log, and we'll say total price called. So now if we save that, head over to our web browser, you'll see a total price was called each of these times. But if we were to come into here and actually comment out the use of total price in the auto run and save that and flip back over, take a look. Even though we've updated the cart by adding new items, notice total price was not recalculated. It doesn't recalculate something unless you actually need it. That's why you can't have, side effects, you can't have error handling and stuff, or you can't throw errors out of these computed properties because their execution is always going to be delayed. But so this is a great way so you never have to worry about maintaining different pieces of state that are related to each other. You just maintain one piece of state, and then from that calculate derived values. As mentioned earlier, there are two types of derivations, computed values and reactions. In the last section, we took a look at computed values. In this section, we're going to take a look at reactions. So reactions are basically used to connect the store to imperative code. So reactions can be used to update the store again, to re-render components, and the reactions can also be configured to run inside of an auto run function. When the auto run callback function executes, it actually sets up the tracking of the observables and the computed properties, which are referenced inside the function, and then reruns that callback function whenever there are new values. Reactive code can also be used to connect up things like making REST service calls, stuff like that. To handle this re-rendering, the observer function provided by MobX React is going to use. So we're going to pull in that MobX React package, and it's going to allow us to set up our components to be observers so they can respond to the changes that occur on the observable. Now the observer can be applied as a decorator or invoked directly on the component itself. Let's do a demonstration now of connecting React to MobX with observers. So now let's go ahead and set this up and move our store to its own file and then incorporate React into our MobX application here. So we're going to come underneath the source folder and create a new folder called stores. Inside of stores, we'll create a new file, and we're going to call this shoppingcart.js. Then we'll come over here and we're going to grab our shopping cart class. Actually, just grab the whole import and shopping cart. Copy that. Paste that into here. Now we can get rid of the use strict because this will be applied globally from the index file. So we can remove that from our import here. We also are not going to require the auto run here. This is just going to be for our observable, computed, and for action. So we'll get rid of auto run. Now we do need to make one slight little change here to our action method. Right now we're just pushing items onto the array, but in reality we're going to need to have a unique key for our React components in order to display our list of items. So we need to add the creation of an actual ID value. So to do this, we're going to say item.id, and we need to figure out whether or not we actually have any items to begin with to then calculate a new ID. So we'll say this.items.length. If the length is actually equal to 0, then we want to do one thing, which is to actually just initialize this to be the number 1. Else, which means if we actually do have items already, we want to calculate the next ID value. You might be tempted to just simply use the item length to actually specify the ID, but this could be problematic because later on, if we add a delete functionality, then you could end up with duplicate IDs, which is what we don't want. So we're going to come and write some code here to actually generate an actual unique code based upon the next ID in the list of IDs in terms of our items. So we're going to say math.max ... this.items.map, and then we'll say I dot ID. So this is going to give us back an array of the IDs, and so we're going to spread those out and pass those into math.max, which will give us the max one that's already being used, and then we'll just add one to it. This actually solves the problem of having duplicate IDs. You'll always generate the next one, which is one greater than the greatest ID in the list. So now we can push our item onto the array. So there's our changes for shopping cart. Now what we need to do is go ahead and create two components that we're going to be using to display our actual items in the cart, and then one to actually add an item to the cart. So we'll come under source here, create a new file. We're going to say cart items.js. We'll add another file here for item form.js. There we go. So let's go ahead and do our cart items first. We're going to import React at the top. There we go. We're going to need to set this up to actually be able to receive the store from MobX. And so we're going to need to decorate this particular component with the observer attribute. So we'll say import observer from MobX React. And we're going to say observer. And we'll do export class cart items extends react.component. And we'll come into here and we're going to say render. Now we're going to be receiving the store in here actually on the props. So let's go ahead and create a quick little table. Return table. And we'll build our t-head, tr, th. And this will be the actual name of the item. We'll have another th for the price of the item. And close off our t-head. Then we're going to need to add a t-body. So we'll say t-body. Now here we're actually going to iterate over the items provided to us by the store. So we're going to say this.props.store.items.map item. And we'll have our tr, close off our tr. And then inside of here we'll have our td. And we're going to say item.name. We'll have another td, item.price, close off that td. On our tr here, we will want to actually add the key value, so we'll say key is equal to item.id. There we go. Now, we'll need a final section down here for our tfoot, which will actually hold our total. So tfoot. And there's our tr. And we'll do a td. And for this, we're going to say total. And then here, we'll just simply say this.props.store.total price. So if we take this and come back over to shopping cart, you'll see we have our total price computed. So this, by referencing total price and by referencing items, when the observer code runs and wraps this code up, it'll actually enable us to be able to track that we're paying attention to these properties on the store, and then of course when they change, it'll trigger a re-render of this particular component. So now we have cart items, we need to actually set up item form. So to set up item form, we'll come into here and say import star as React from React. So now let's go ahead and create our component, export class item form extends react.component. There we go. So now inside of here we need to build ourselves a little form. So we're going to actually add some React component state as we talked about in the slides. So we'll say super props this.state is equal to, and then we're going to have item name, and we'll have item price. Now, as mentioned before, this is not the same as our MobX state. This is actually just state that's within React to actually allow us to have controlled components and collect our data. For this, we will need an onChange function. We'll use arrow functions here to do this. This way we don't lose our context of this. And we'll say this.setState. And then we'll use the usual formula, we'll just do target dot name and target dot value. Now, of course, we're collecting both a string and a number here, so really we should do a quick check on the type to make sure we are using a string versus a number, or text versus a number, so that we can do the appropriate conversion. So if in fact we are using a number, then we're going to want to convert that to a number. If we are not using a number, we'll just simply grab the value as is, which will always come off as a string. This will ensure that our total price can update its calculation properly. So there's our onChange there. So now next on our list of things to do is we're going to need to actually build our form. So we'll say render. And we're going to do a return form. Close off our form tag there. Come into here now, and we're going to add our first input control. There's our div. We'll have ourselves a label, and we'll say item name. Go ahead and put a colon there. Add an input field. So type equal to text, and then we'll have our ID, item, name, input. We can actually use this ID to connect up the label to the input field. We'll then need to specify value, which will be this.state.item name. And let's go ahead and move that down to the next line, make it a little easier to read, and then we'll wire up the onChange for typing into the field. So this.onChange. So there's our first input field. Let's go ahead now and set up the second one. Come into here. We're going to do our multi-select here. We're going to grab our D, name. Oh, a little too far. All right, so let's take that right there and say name and change that to be price. And then we'll grab this one, D, price, and we're going to change this text to number. Now if you remember up here in our onChange, we set it up to actually look for the target.name to know the computed property here to set on our object literal. This computed property is not the same thing as a computed property with MobX. This is actually a computed property in JavaScript. And so we can programmatically set this based upon the target's name. So down here on our input fields, we'll need to add an additional attribute for name and say item name, and then here name item price. you'll see that item name corresponds to this, which then corresponds to this. Item price is the same way. Item price corresponds to this, which then corresponds to this, allowing setting our property on our state to work properly. So now that we have that set up, let's go ahead and add a button. So type equal to button, and we're going to say add item. The reason we say type equal to button here is when you're working with HTML5 forms and you put a button inside the form, the default behavior is to submit to the server, which we don't want to do. We actually want to run a piece of JavaScript code. So we can say type equal to button, and that takes care of that problem. So now we can say on click this dot add item, and we're going to come up to here and create an actual add item function. So add item. Now what's going to happen here is we're going to actually say this dot store dot add. So if you come back over here in shopping cart, remember we have our add function. And we're going to say add, and we're going to actually take the data off the state. And in reality, we could actually just pass in this dot state dot item if we had set it up like that, but we're going to have to do a little bit of a mapping here. And we're going to say this dot state dot add, and we're going to specify name, and then we'll say this dot state dot item name, and then we'll say price, this dot state dot item price. And of course, the final step here is this dot set state, and we'll reinitialize our item name and item price fields. So now you'll see that we're using this component state only for the purposes of collecting form data the React way, and then actually storing our real application state and everything up here in the store. Now, depending upon who you talk to, a lot of folks would make the argument, well, this form state should really be tracked inside of MobX. But the reason I'm doing it this way is I really want to draw this hard line between what's really application state and then what is this thing called state inside of React. Just because React happened to call this thing state, we shouldn't really confuse the two. And a lot of folks do because of the similarity of the name. But in reality, we want to think about what these things stand for conceptually. And any other framework or library that just simply lets you type into the box, you wouldn't sit there and try to push the actual typing into the box up into your MobX store. The only reason you would do that here with React is because it happens to have a similar name. So I want people to think about what's the real difference here with the data that we're collecting and what is library and framework specific and is not really the larger picture but may share a same name. So let's go ahead and save that. So there's item form. Now we've typed out a fair amount of code here. There's probably a bug in here somewhere, but we have a little bit more code to go before we can run this. We need to come over to app, and we're going to need to import both of these into app and then place them down here. So we're going to say import, and we'll say car items from car items, and import item form from /item form. And we'll take our car items here. We'll say store equal to this.props.store. Always make sure you include the props here. Sometimes when I'm writing out my code really fast and I'm using a store, I'll forget to put the word props, and I'll just say this.store. Remember, all the same React rules apply for passing the store down. And let's go ahead and just copy that and then replace that with item form. So now we have car items and item form, and they're receiving the store, which of course now means app needs to receive the store. No problem. We can come over to here and we'll keep the use strict part. So now we can get rid of the shopping cart here as we are going to be importing that. We can still instantiate it. We'll also get rid of the auto run and the ads. Pull all that up. So now let's come into here and actually import our shopping cart. So we'll say import from /stores/shopping cart. And we'll grab our shopping cart class right there and just simply import that in directly. So now we can new this up, and then we can take the shopping cart store itself and actually pass that into app just like that. So now if you take a look, we are creating a shopping cart. We are passing it into the app, and now we have the ability to go ahead and run this code and see if it works and fix any bugs that occur. So npm start. We'll actually fire this whole thing up again in case you stopped your program and let it do its processing. There's our web browser. We'll see if we get any compilation errors. All right, looks like we have a little compilation error here. In our store shopping cart does not export anything named shopping cart. So if we head over to shopping cart, forgot to put the word export in front of class. Whenever you have a bunch of things to find in one file and you move it out to another file, it's really important to remember to do the whole export process. Okay, we also have cart items, nothing export cart items. In our app.js file here, we actually have cart. We have car instead of cart. And let's just replace that and add a T in there. All right, great. Everything looks like it built. Only 2 compile errors with all those code changes. Not too bad. Now let's jump over to our web browser here and see what we got. Looks like we have our table with our price. We have our item name and our item price. Let's go ahead and type in our item name here. And we're going to say computer. And then we'll come down to this field and say 3000. Let's put a 3 there. Sometimes those number fields can be a little bit of a pain to interact with. And let's go ahead and click on Add Item. All right, so we have this cannot read property add of undefined, and because I forgot to put props. So let's go back here and actually add props for our form. I had just mentioned a second ago I'll forget to put props there, so let's put the props in. But one nice thing about this Create React App tool is the way it does the error handling in terms of giving you the screen in the web browser. A lot of times you'd have to have your console open to actually see the errors, which is always really a best practice, but it's really nice to get the information to pop up like it does. So let's come into here now and let's type in a new item. We'll say computer, and then we'll come into here and type in 3000. And we'll click Add Item. Hey, there we go. There's our computer with a price of 3000. We'll add in our mouse again, make it a price of 50. Click Add Item, and now you can see everything is updating properly. So now we're using MobX to track our application data. We're still using our React component state to collect our form data. We're able to apply the observer to cart items. And because it's paying attention to items and to total price, whenever those get updated, this gets re-rendered. Notice that we are passing the store into app, but we don't actually have app registered as an observer. As long as app doesn't need to react to the change of the MobX store directly, you don't have to put observer at the top of it. Same thing is true for item form. You'll notice we don't have observer applied here either, even though we are calling add function on the store to trigger the update. The observer only has to be added to components that are going to be receiving updated data, either as an observable or as a computed value. One of the things about using MobX or even Redux with React is how do we make the store available to the components in the component tree. Now, depending upon what type of state management container you're using, you might be connecting it just into a couple of components, or you might be connecting it into all of the components. Anyways, there has to be a way for this to be made available to the component tree so that the actual values on the state can be easily used. Now, one way of doing this with React is to pass the store actually down through the props. This actually proves to be quite tedious and really frustrating for the most part, especially with larger component trees. So instead, we can use something called React's context. Context can be thought of as like a global scope for the tree of components. So the idea is you make the store available on the context, and then with very little setup, all of the components in the tree can actually access that. Well, turns out there's actually a special provider component provided by MobX React that does exactly that. The provider component wraps your top-level React component, and then sets up the MobX store on the context. And then you can use the inject decorator on your components to actually inject that store into your components. Now, unlike Redux, where you have only one store, you can have many stores in MobX. So the inject function can actually be used to specifically identify which stores are injected into which components. So take a look at this here. We have our React DOM render, our provider with our app. We're passing in our store, and then we can utilize that store inside of our component by having it marked as @observer, and then using @inject and injecting the store into our component. Let's do a demonstration now of using provider and inject to pass the MobX store. For our final demonstration here, let's take a look at how we can use the provider to make the store available on the context. This will actually make it a little bit easier to make the store available to components in the tree, especially since the components themselves will be directly connecting to the store. This becomes like a big deal. It can save a lot of time and effort in having to pass that store all the way down through the props constantly. To do this, we're going to import the provider from MobX React. We're going to take the provider and wrap it around the app component. So we'll copy that there, paste that, and then let's go ahead and copy that. Go ahead and close off that component. We're going to take the store here and move that off of the app and put that up onto the actual provider itself. Okay, so now we're going to pass the store, pass the shopping cart in via the provider. We now need to set it up for the cart items and for item form to receive it directly, which means we can actually get rid of this code here to pass it down directly, because now it's going to be made available to us in those components. We'll go ahead and save that. Now let's jump over to cart items, and we'll do it here first. We're going to say inject. In here, we're going to decorate this by saying @inject, and then we'll say store. This will make this available on the props, the store. And then we're going to take this piece of code, and we're going to copy it and save, and come over to item form. Now, item form doesn't need observer, it just needs inject, so we can get rid of that. So you'll notice you don't have to have an observer on a component in order to inject the store. The component's not going to respond to any, not going to react to any changes to the store, but it can still call the action functions that are available on the store to trigger other components to react to those changes. Save that. And then we're going to come over to here, and we'll go ahead and do our computer 3000. Click add item. Boom, there's our computer. And we'll go ahead and add our mouse. There's our 50 and add item, and our total is updated. So now we don't have to sit there and pass that all the way down to the component tree. We can simply inject it in as needed because it was registered with the provider, and this makes life a lot easier. So in conclusion, we've learned that MobX is a state management library commonly used with React, but it doesn't have to be used with React. MobX uses a strategy of tracked observables to store state. Action functions are used to mutate the data contained in the observables, and then functions that are explicitly marked as action functions must be used when MobX is in strict mode. When an observable is changed, derivations execute reactions which use the observables and computed values to update the user interface and perform other operations, such as REST service calls. Decorators can be used, but are not required. They do require the legacy form of decorators, which you can set up through a Babel plugin, or you can get from TypeScript. And then finally, unlike Redux, MobX is designed for multiple stores, and the data is actually mutated on the state. The provider component with the inject function is used to support the passing of specific stores into components.